All right, guys, so I had a couple people ask questions about the Simplifying Radicals worksheet, so I'm going to try and do a video. I don't know how well this is going to work, so we can talk about it later about the video quality. So the people who are asking questions are getting stuck here at 25 through, I think it's 30 that's on this. But I'm going to go back to 22, and I'm going to give you a refresher on how you do that. So the first step you want to do is the factor tree. So we're going to take 405, and we're going to break it down into two numbers that multiply to give you 405. So checking on a calculator or on Desmos, I found that 15 multiplied to 27 can give you 405. Next, you want to check, are these prime numbers? Is 15 a prime number? Meaning, is there anything that can multiply to get you 15? If there's not, then it's prime. If there is, then it's not prime. So in this case, 15 is not prime because you can take 5 times 3 to get 15. So 27, is 27 prime? Are there two things that can multiply to give you 27? So in this case, there is. So the two things that I found to give you 27 is 9 and 3. So do the same kind of steps with these numbers now. Is 5 prime? Meaning, is there anything that can multiply to give you 5? The only way is 5 times 1. So that's what we consider prime. So I'm going to put a line under it to say that I'm stopping there. So now checking 3, is 3 prime? Yes, because there's nothing that multiplies to give you 3. Now looking at 9, is 9 prime? No, 9's not prime because you can take 3 times 3. So again, we've already decided that 3 is prime, so we're going to stop here. So then I'm going to write all these out in order from least to greatest. So I have 1, 2, 3, 4 3s. So 1, 2, 3, 4 3s, and 1 5. So remember, to check to make sure that you did this right, you can go ahead and multiply these, and you should get back 405. So if you would do 3 times 3 times 3 times 3 times 5, we should get 405, which we do. Now, this is a square root. So with a square root, you're looking for pairs, meaning two of the same kind. So in this case, we have a pair of 3. So we have one pair of 3, so I'm going to write 1 3. Here we have another pair of 3s. So I'm going to write another 3 to represent that other pair. So this 5, though, doesn't have a pair. So it stays inside because it doesn't have someone to come out with. So simplifying this, what is 3 times 3? So 3 times 3 is 9, and we get 9 square roots of 5. In Desmos, you can check this. So you can type in the square root of 405 and then type in 9 square roots of 5, and you will get the same decimal. If you don't get the same decimal, you did something wrong. So that's a way that you can check yourself. Now, I'm going to show you how 25 through 30 is a little bit different. So first of all, hold on, let me go back up to 22. Notice at 25, it has this little 3 on the outside. This one had nothing. So this is what we call a square root. This is what we call a cubed root. Square roots, we were looking for 2 of a kind. Cubed roots, you're looking for 3 of a kind. So if we take 56, we're going to do the same thing. Find two numbers that multiply to give you 56. So in this case, 56, you can do 8 times 7. Now, it's okay if you pick different numbers at the beginning than what I do. I know you can also get 56 by doing 2 times 28. So if you start with 2 and 28, that's fine too. In the end, you'll get the same answer. So we have to ask ourselves, is 8 prime? No, because you can get 8 by multiplying 4 times 2. Okay, 7, is 7 prime? Yes, there's no two numbers that multiply to give you 7. If you can't remember all the prime numbers, you can always Google search for what are the top 100 prime numbers, and usually you can find a list. So next, looking at 4, is 4 prime? No. 4 can be broken down into 2 times 2. Is this 2 prime? Yes. So since we're already saying that this 2 is prime, that means these 2's are prime as well. So now, just like here where we wrote out our factors, we're going to do that here too. So 2 times 2 times 2 times 7. So remember, up here, square root, looking for 2 of a kind. Down here, cubed root, looking for 3 of a kind. So in this case, we do have 1, 2, 3 2's. So that is going to be our set. Instead of just 2 of them, we have 3 of them. So just like how we brought out 1, 3 to represent this pair, we're going to bring out 1, 2 to represent this triplet. Since the 7 does not have 2 other ones to go with, it's going to stay inside of the radical. So instead of writing it as a square root, though, you can't forget to write it as a cubed root. So this is going to be 2 cubed roots of 7. And this is going to be your answer. Again, you can always check yourself. So when you multiply these all together, you should have gotten back 56. And when you put this in the calculator and this in the, not the calculator, but Desmos, if you have the calculator, awesome. If not, you have Desmos. So you can put this in Desmos and this, and you should get the same decimal. If not, you messed up somewhere. So these are a little bit different, but not really. So it's negative, okay? With a negative, you just bring a negative. You're just going to ignore it until the answer, and the answer is just going to be negative. So you're going to follow this the same way that we did number 25. So we have 128, and we need to find 2 numbers that multiply us to give us 128. So let me go through some numbers real quick. It looks like 4 and 32 give you 128. Again, you do not have to begin with the same numbers that I do, as long as you end up with the same last couple numbers at the end that you have underlined. So then 4 breaks apart into 2 and 2. These are both prime. 32 breaks into 8 and 4. 8 breaks into 4 and 2. 4 breaks into 2 and 2. These are all prime. And then this last 4 breaks into 2 and 2. That's a lot of 2's, but that's okay. So 1, 2, 3, 4, 5, 6, 7. So we have 7 2's. So I'm going to go up here and write those out. Okay, and again, we're looking for the cubed root, not the square root, the cubed root. So cubed root means you need 3 of a kind. So we're going to circle these 3, and then this one doesn't have a set of 3 to go with. So I'm going to take 1, 2 to represent this 3, 1, 2 to represent this 3, and then this 2 is going to stay inside of the cubed root. So then I'm going to take 2 times 2, which is 4. I'm going to get 4 cubed roots of 2, but remember this negative sign here, so that means this problem is going to be a negative. So this is our answer. I hope this helps. If you need anything else, let me know.